Hi students, welcome back to Sankalp classes. Welcome back to Sankalp classes. Welcome back to Sankalp classes. Hi students, welcome back to Sankalp classes. The question is, if R is defined by has same reminder mod phi, then R is, you have to check equivalence, antisymmetric, not transitive, not reflexive. Okay. So what do you mean by A congruent modulo B n or A congruent to B mod n? So if you know the definition of congruent modulo n, it's easy to solve. Hello students, welcome back to Sankalp learning classes. The question is, if R is defined by has same remainder mod phi, then you need to check R is equivalent, antisymmetric, transitive or reflexive. Okay. What do you mean by congruence modulo? Hi students, welcome back to Sankalp learning classes. Take the question. If R is defined by has same remainder mod phi, then you need to check R is equivalence, antisymmetric or transitive or reflexive. What do you mean by A congruent to B, or you can even take one more line here, B mod N. What it means? A minus B is divisible by N. Here in this case, instead of N, you have phi. If A minus B is divisible by phi, then can you say B minus A is divisible by B minus A is divisible by phi? Definitely only negative value you are going to get. So R is symmetric. Now check reflexive. A minus A. Is it divisible by 5? 0? 0 only, correct? So it is reflexive. Next, check transitivity. A minus B is divisible by 5. B minus C is divisible by 5. Then definitely A minus C will be divisible by 5. That implies R is transitive. Got it? So A minus C is also divisible by 5. R is transitive. We have proved R is reflexive, R is symmetric, and R is transitive. So option A, equivalence relation, that is true. This is wrong. So the answer is R is an equivalence relation. Got it? Hi students. The question is, composition is associative. H composition G, composition F equals to option A, H composition, G composition, F composition, G composition, H, G composition, H composition, F, none. So let us check. What do you mean by associative property? In general, not with respect to composition. How do you define associative? How do you define associative property? A plus B plus C is equal to A plus B plus C. With respect to addition, you can write associative property like this. Okay, same way here, instead of plus, you have composition symbol. That's it. Okay, so how can you write H composition, G composition, F? You can write it as H composition, G composition, F. Correct? So general, it's like general associative property. So option A, H composition, G composition, F is the correct answer. You can't shuffle, but you can take the order in different way. Okay? So this is not correct. This is also not correct. So the answer is H composition, G composition, F. Thank you. Hi students. The question is, if f from A to B with cardinality of A is equal to 3, cardinality of B is equal to 3, and f is 1, 1, then you need to check f is onto or not. Okay? So suppose f is 1, 1 and the domain has 3 elements and codomain also has 3 elements. So A is 3, B is mod B is 3, or cardinality of A is 3, cardinality of B is 3. See the figure here. So here also domain has 3 elements, codomain also has 3 elements. To be 1, 1, each element of domain should map to distinct elements of codomain. Correct? So each element of domain is going to map the distinct elements of codomain. Since codomain also has 3 elements, is there any possibility that any element which does not have any pre-image? Check in this. 3 is mapped, 2 is also mapped, 1 is also mapped. So there is no element which does not have pre-image. Therefore, if there is no elements left out here in the codomain, then it must be onto. Correct? So F is also onto. So option C is the correct answer. Got it right? Thank you. Hi students. The question is, if f of x is equal to e power x from R to the open interval 0 to infinity, then you need to find f inverse x. You have already studied e power x and log x, right? The function, exponential function and logarithmic function. These two are always inverses of each other. E power x is inverse of log x and log x is inverse of e power x. Okay? So, if you multiply, one more important concept is, if you multiply these two, what will you get? If you multiply a and 1 by a, what will you get? 1. Similarly, here also, you are going to get identity function. Correct? Therefore, if this is satisfied, then you can say e power x is inverse of log x, or log x is inverse of e power x. So, see the question. Inverse of f. F is e power x. Therefore, f inverse x must be log x ln of x. This option B is correct. Here, range is 0 to infinity because log x is defined in this interval. Therefore, range is 0 to infinity. So, the answer is option B, ln of x. Thank you. Hi students. If R is an equivalence relation on A, number of distinct equivalence classes partitions A. For A with 4 elements, maximum classes equal to. So R is an equivalence relation on A. distinct equivalence classes, partitions A, and for A with 4 elements, A has 4 elements, then you need to check maximum how many equivalence classes you can form. Okay? Since the classes are distinct, suppose you take A is equal to, or you take A, B, C, D. The distinct classes maximum how many you can do? A, B, C, D. Correct? So possible number of classes 4, isn't it? Correct? So how many elements are there in A? That many classes you can form. Therefore, option D, 4 is the correct answer. Thank you. Hi students, the question is, if f of x is equal to ax plus b, a not equal to 0, then you need to find f inverse x. Okay? So f of x is equal to ax plus b. Take y as f of x. So y is equal to ax plus b. Correct? So y is equal to ax plus b. You find now x from this linear equation. So how do you find? Y minus b is equal to ax, or x is equal to, what? What's x? Y minus b by x. Correct? So now, y minus b by a. You are finding x. So now, this will be f inverse x if you replace y by x. So it is x minus b by a. Okay, so f inverse x is equal to x minus b by a. Again, go through it. First, what you have to do? You have to take f of x as y. So y is equal to ax plus b, because f of x is equal to ax plus b. Rearrange and find x. So x is equal to y minus b by a. So f inverse x will be x minus b by a. Here you are changing y to x. That's it. Or you are replacing y by x. Then you will get f inverse x. Therefore, f inverse x is equal to x minus b by a. So, which option is correct? Option C is the correct answer. Thank you. Hi everyone. The question is, if f from 1 to ab with f of 1 is equal to a, f of 2 is equal to a, then composition f is, whether it is bijective, whether it is defined or not defined, you need to check. Okay. Now, what is given? F from 1 to 2 to A to B, correct? Is defined as f of 1 is equal to A, f of 2 is equal to A. Both 1, 2, both are mapped to A only. B is not mapped. So if B is not mapped, then it is not onto. So the first option, bijective, you can discard. So B bijective, it should be both 1, 1 and onto. Okay. It's not bijective. Now, F composition F. Is it defined? Is it defined? Hi everyone. Take the question. If F from 1 to 2ab with f of 1 is equal to a, f of 2 is equal to a, then composition f is, you need to check whether it is bijective, defined, undefined, or none of this. Okay. So what is given? F is from 1 to 2. F is from 1 to 2. AB, and f of 1 is equal to what? It is A. And f of 2, what's given? It is also A. Correct? So f of 1 is also A, f of 2 is also A, and there are only 2 elements in the domain. So both the elements are mapped to A. Correct? So it is a constant function basically. Constant function, and it is defined as f of x is equal to A. Okay. So now check F composition F. F composition F. What is F composition F? F of x. What is f of x? It is f of, what is f of x? It's A. Correct? But what is f of a? What is f of a? You cannot find because f composition f should be from where to where? See, f is from where to where? It is 1, 2 to AB. If f is, if this and this both are same, then the domain can be this. Now these two are not same. So f composition f is not defined. So the option C, not undefined, is the correct answer. C, to have composition map, the codomain of the first function must be the domain of the next function. Okay, here in this case, if both are same domain and codomain, then only it is possible. Otherwise, it's not possible. Therefore, F composition F is not defined. Thank you. Hi everyone. The question is, two equivalence classes are either identical or option A overlapping, B identical, C disjoint, D none of these. The two equivalence classes are identical if they have common element. Otherwise, they must be disjoint. See here, A, B, C. If B is common, then that is identical. Here in this partition, A, B and C, one more partition. There's no common element between these two. Then they must be disjoint. So two equivalence classes are either identical or they are disjoint. What do you mean by disjoint? There's no common element. So check the options. Overlapping, it's not correct. Identical, no. So disjoint is the correct answer. Thank you. Hello students. The question is, if f from A to B is bijective, then number of elements in f of A. F of A means range is. So if a function is bijective, then number of elements in domain must be equal to number of elements in codomain. In this case, A is the domain, B is codomain. So mod A must be equal to mod B. Always range should be subset or equal to codomain. Okay, but since the function is bijective, it is 1, 1 and on 2. It's 1, 1 and on 2. Whenever a function is on 2, then f of a must be equal to b. Okay, range must be equal to codomain. That implies number of elements in B must be equal to number of elements in f of A. But number of elements in B is also equal to number of elements in A. Therefore, number of elements in f of A must be equal to cardinality of A or mod A. So check the option. Option A less than mod A. Option B equal to mod A. Option C is greater than mod A. It is also not true. Okay, option B equal to mod A is the correct answer. Okay, thank you. Hi students, if f of x is equal to tan x restricted to open interval minus pi by 2 to pi by 2, it is option A 1 1 and on 2, option B not 1 1, option C 1 1 but not on 2, option D none of these. Okay, you need to check this. Tan x function is tan x. Okay, see any function between 0 to pi by 2, sine, cos, tan, whatever. If you apply the function like sin x, sine pi by 3 and sine pi by 6, any in between 0 to pi by 2 or minus pi by 2 to 0, they are not equal. Correct? You can check it, pi by 3, pi by 4, pi by 2. None of them are equal, right? In case of sin x or in case of cos x or in case of tan x. And tan of minus pi by 2 is equal to minus infinity because tan is sin by cos. Sin pi by 2 is what? 1. Cos pi by 2 is 0. Denominator is 0. So tan pi minus pi by 2 is minus infinity and tan pi by 2 is infinity. Okay, so the range lies between the whole real numbers. And in between minus pi by 2 to pi by 2, distinct elements maps to distinct images. So it is 1, 1. Since the range is minus infinity to infinity, it covers all the values. It is on 2 also. Okay, therefore tan x is in this domain only. If you extend it to real value, it is not 1, 1 and on 2. But tan x in minus pi by 2 to pi by 2, it is 1 and onto it is bijective. Okay. So option A is the correct answer. Thank you. Hello everyone. The question is, let f from R to R be defined by f of x is equal to 3x minus 4. Then f inverse x is given by. You need to check those 4 options. Okay. Usual procedure. What you have to take? Take f of x is equal to y. Okay. But what is f of x? What is given? F of x is defined like this, right? So y is equal to 3x minus 4. Now what is the next step? Find x. X must be equal to, move this 4 to the other side. So it is y plus 4 divided by 3. What is the next step? To find inverse? What is the next step? F inverse x is equal to, replace y by x. X plus 4 divided by 3. Got it? Okay, first step you need to take f of x is equal to y. So f of x value is given. Substitute it, simplify for x. Then replace y by this y. Replace this y by x. You are going to get f inverse x value. So option A, x plus 4 by 3 is the correct answer. Thank you. Hi students, the question is, let n be the set of natural numbers and the function f from n to n, function f from n to n be defined by f of n is equal to 2n plus 3 for all n belongs to n. Then f is, you need to check, surjective, injective, bijective, or none of these. Okay. So what is given? What's given? Function is from where to where? It's from n to n. N means set of naturals. Okay. What are the elements in n? What are the elements? So it will start from 1, 2, 3, so on. Right? And how f is defined? F of n is equal to what? F of n is equal to 2n plus 3. Correct? Now what is f of 1? In place of n, what you have to put? You have to put 1. If you are putting in the LHS, you have to put in the RHS also. So 2 into 1 plus 3. So what's f of 1? It is 5. Is that correct? What is f of 2? 2 into 2 plus 3. It is 7. Similarly, what is f of 3? 2 into what? 3 plus 3. So it is 9. It continues like that. Okay. So clearly this, for distinct elements you have distinct images. So f is clearly 1 1. But what about on 2? What's the range? 5 7 9 11, like that it continues. But C n contains 1 2 3 so on. So 1 2 and all these elements, they don't have pre-image, right? These elements do not have pre-image. That means it is not what? Surjective or onto. So function is 1 1 but not onto. What's the other name for 1 1? What's the other name? Injective. What's the other name for onto? Surjective. So the function is injective, but it is not surjective. So it's not surjective, it's injective. Since it is not surjective, it is not bijective also. Therefore, option B, injective, is the correct answer. Thank you. Hi everyone. Let L denote the set of all straight lines in a plane. Let a relation R be defined by LRM if and only if L is perpendicular to M for all Lm belongs to L. Then R is, you need to check, reflexive, symmetric, transitive, none of this. So what is given? L is a set which contains the lines which are perpendicular. So the relation is, suppose L and M are the lines. Relation L R M is L perpendicular to M. Correct? So you need to check whether it is reflexive or not. In place of M, you have to take L again. Is L perpendicular to itself? Definitely no. Therefore, since L is not perpendicular to L, R is not reflexive. R is not reflexive. Okay? Now, L is perpendicular to M. Can I write M is perpendicular to L? The ulta of that, if L is perpendicular to M, see here in this figure also you can check. L is perpendicular to M. Then M is also perpendicular to L, correct? So therefore, if L is perpendicular to M, then M is also perpendicular to L. That implies R is symmetric. R is symmetric. Next, check transitive. L is perpendicular to M. M is perpendicular to N. See in this figure. L is perpendicular to M and M is perpendicular to N. Then N and L are parallel. They are not perpendicular. Therefore, what you can say? Therefore, L is not perpendicular to N. Actually, L is parallel to N. Correct? L is parallel to N. Implies R is not transitive. R is not transitive. Check the options now. So option A, reflexive, is not correct. Option B, symmetric is the correct answer. And option C, transitive, is also not correct. The last option, none of these. Okay, so option B, symmetric is the correct answer. Thank you. Hello students. The question is, for real numbers x and y, define x or y if and only if x minus y plus root 2 is an irrational number. Then the relation R is, you need to check, transitive, symmetric, reflexive, none of this. Okay. So first you check whether it is reflexive or not. How do you check? Relation is defined x minus y plus root 2 is an irrational number. So how do you check reflexive? Replace y by x. X minus x plus root 2. That is 0 plus root 2. Is it irrational? Definitely it is an irrational number. Therefore, R is reflexive. R is reflexive. Now, check symmetric. X minus y plus root 2 is an irrational number, then check whether y minus x plus root 2 is an irrational number or not. Actually, it may or may not be irrational. If it is anything like y minus x is anything like minus 2 or plus 2, whatever, it is irrational. But if y minus x is minus root 2, then the whole thing will be minus root 2 plus root 2, it is 0, which is not irrational. This possibility is there. To prove, you have to prove for all values. But to disprove, if you show one, that is enough. So in this case, it is not irrational. Therefore, R is not symmetric. Okay. Now check transitivity. So x minus y root plus root 2 is symmetric. X minus y plus root 2 is irrational. And y minus z root 2 is irrational. Then check whether x minus z plus root 2 is irrational or not. So for that, what you have to do, add these two. So what will you get? X minus y plus y minus z plus root 2 plus root 2. So that is equal to x minus z plus 2 root 2. Correct? So if x minus z is minus 2 root 2, then whole quantity reduces to 0. Whole quantity reduces to 0, which is not irrational. Therefore, R is not transitive. So R is not transitive when x minus z is minus 2 root 2. So you can discard this. It is not symmetric. It is reflexive, we have proved. So option C, reflexive, is the correct answer. Hi students, the question is, let f from R to R be defined by f of x is equal to x square plus 1. Then the pre-image of 17 and minus 3 respectively are. So what is given here? F is from R to R. F of x is equal to x square plus 1. So you need to find pre-image of the image 17 and minus 3. So 17 must be equal to x square plus 1. X square plus 1 is equal to 17. This implies x square is equal to 16. That implies x is equal to plus or minus 4. Correct? Now take the other case. X square plus 1 is equal to minus 3. So you need to find pre-image for minus 3. So equate f of x to minus 3. This implies x square is equal to minus 4. That implies x is equal to what? Plus or minus? Is it 2? No, minus is there. Therefore, plus or minus 2i. This is it a real number? Is it a real number? No, it is complex because you have imaginary part I. So, this is not possible, correct? So, you can take this as empty. Okay. So, which is the option? Option C is the correct answer. Plus or minus 4, and this is empty because this does not belong to set of reals. Okay, final answer is option C, 4 minus 4, 5. Thank you.